Okay friends, we are going to discuss a portion of load flow analysis by Power Factory DXIsland. Now first open DXIsland, close templates, we can select any one, distributions, anything. Go to file and here new, project, and give a name of the project. For example, I give the name of project A AAA, then OK. It comes that you select the grade. We select here the frequency of the grade and the name of the grade. We can give the owner any. For example, I give ABC, then OK. Again, first we select the buses. These are the icons of our required icons are in the right side. First, in any definition of the system, first we give the bus bars and we define the voltages of the bus bars. Here, bus bar. We bring in a work space, click here, then another bus bar. We select only two bus bar for easy and easier understanding. Then escape to go away from selection of the bus bar. Press escape. Then define each bus bar, the name of the bus bar, then define the type of the bus bar. Here we select new project from because we want to define, we want to give the characteristics of these bus bars, so we select new project. The name of the bus bar, I select bus bar 1 and I give the voltage of this bus bar, rated voltage 110 kilovolt. Then OK. Here are the type of the system. AC system is there, and here we have used as a bus bar. We can define it as a junction node or internal node also. We select here bus bar only. The first terminology ABC and the line to line voltage 110 kilovolt, and line to ground volt has been defined itself. If I change the line to line voltage, then the line to the ground voltage will be changed. I do not earth this bus bar, so I do not click the earth it. These are the parameters given to the bus bar. The target voltage 1 per unit and its rated voltage is 110. Maximum voltage 5%, and here the maximum voltage allowed per unit is 1.05. Minimum voltage per unit is 0. The definition relates to the bus bars. Then OK. Next, definition of another bus bar. We go to the basics and these are the terminal name. Then define a new project type of the bus bar. Then go to the basic. From the basic you type the name of bus bar. I select bus bar 2 and rated voltage 110. Then OK. Again select AC bus bar, the same as the previous. ABC line to line to the ground voltage. These are the definitions into load flow analysis required. Now the two bus bars are defined. I have drawn the bus bars. I have defined the parameters. Now I want a source to feed to this bus bar. I can select a synchronous machine also. If you go the mouse by mouse to each icons, they have been shown the name of each icon, what this icon represent on. This is synchronous machine, asynchronous machines, and maybe we can feed from the grade, external grade. I select external grade and I bring it to feed. here. From the grid it is fed to the bus bar. Next, click escape, go connect two bus bars by line, transmission line, two bus bars. Okay, it's connected. Then escape, go and select a load. This is the load connected. Now define each new components required to be defined and that we have joined to our system. The first one, our grid. This is the source that is fed to the bus bar number 1, and from bus bar number 1 to bus bar number 2. In connecting of transmission line, we should remember that we should select first that bus bar that the source is connected to. For example, I cannot connect the transmission line from 2 to 1. I should connect from 1 to 2 bus, from bus number 1 to bus number 2. Then go to define each parameters of the components. Go to the basic. This is gentle. The name, it's given external grid. You can give grid, you can give any name. And for the definition, go select, and there are another parameters that we do not want to discuss now. Here, go to the load flow. Select the type of the grid. When we feed from the source to any bus bar, here, when we feed from source to any bus bar, according to the load flow analysis theory that we have already learned, that here we define one per unit the voltage and the type of the bus bar. This bus is a slug bus. So I select the parameters of the source, that this source is connected to which bus, to the type of the bus. That bus is slug bus. Here the voltage 1 per unit. When I select the type of the bus, immediately the parameters becomes automatically like this. In slug bus it becomes one voltage 1 per unit and an angle of 0 degree. If I select PV, there are another parameters that we need to define it. And if PQ, another parameters are required to be defined by us. Then I select slug bus. Go here, we do not define anything. Then all has been done regarding to our source or the grid feeder. Okay. Then the transmission line, define the parameters. Go, this is the name of that line number 1 I give. Select the type, select the global type, or select a new project type that we want to define this new line. Then there are required load flow parameters that should be defined. That whenever anyone works in a company, they should know that this transmission line or this cable has this maximum operational temperature is 80 degree, like these parameters that are the type of the material, copper, or you can select any other material. We select copper here, the resistance, AC resistance in 20 degrees Celsius, this much per ohm per kilometer. We go through the basic data, line type and rated voltage. Here the rated voltage we select as a bus bar rated voltage 110. Then the current 1 ampere, we leave it as this. The normal frequency that we have already defined at the first when we want to start the project, on the new project starting. Then the type of the transmission line that we use, this line is a cable or overhead line. We select overhead lines. The system type is AC 3-phase and neutral. How many numbers of neutral? If we want in a transmission line that we have 4 lines, then we select number of neutrals 1, and we should define all the parameters of the neutral line. Here we do not connect any neutral line. Select 0. Then go define the parameters of length, positive and negative sequence, and zero sequence of a transmission line. Here I give approximate values, my desired value, but in a real project you should give the real values of the positive and negative sequence, resistance and impedance of the transmission line. But the point here that I should in transmission line, we know that zero sequence component is twice or greater than twice of the positive and negative sequence impedances. Here I gave us resistance of 1.45, like any value you gave, and 0.674. Here the resistance, if you want to give an approximate values, or if you want to give your arbitrary value, it should be at least twice. Twice of 1.42 something it becomes. I give 6 point something, and here it becomes around 4 point these values. Okay, the parameters has been defined by us, and all the parameters, yes. Now click OK. Now here you can see the resulting values, that rated currents, positive sequence impedance, and positive sequence impedance angle is this match. All these calculated by the software itself. Here one thing more that we want. Here we have drawn a single line diagram of our system, so we do not consider another parallel number of the lines. Hence we select the parallel number, only one line here. The length of the line we select, for example, in kilometers, 100 kilometers. Their line model of the line, this is lumped or distributed. We select the lump. Distributed can be for long transmission line of 250 or 280 above. The line that we have selected is 100 kilometers, so we select the lump parameters. Now, okay, thermal loading limit means that in our system, when our system is loaded 100%, then it reaches to the maximum thermal capacity, like these parameters that are not related to our project now. We will discuss it later. Select OK. Now line is defined. Now go for definition of the load. Select type general load. Here you can give, and in a load, the system is AC. We can give the name of the load any. The system is AC, and the technology. How can we connect? How do we connect these loads? We select three-phase, face-to-face to earth here, three-phase to neutral or YN also we can select, three-phase delta connected also, star connected also. And these are the voltage dependence that if we have. Here we do not consider, so we do not go anywhere. Define, okay. Then load flow. In the load flow here, we should define the load. We know from our load flow analysis that here we have defined this bus bar as a slug bus. This is load bus. In load bus, what we know as our requirement, we know this society how much active power and reactive power do they require. So for this load, we should define the amount of required active and reactive power. Then from load flow analysis, we understand that how much current will flow this transmission line, how much will be the active and reactive power on our slack bus. Here we gave some values for the active power. For example, 9.434, reactive power of 4.63, voltage per unit and scaling. Okay, if you wanted to have a remote control to these loads, so we tick mark this, and we also define it. Here we do not, hence just okay. Now all the components are connected. Here all the parameters for each one has been defined, hence we go to calculate. What do we want to calculate? The load flow. Calculation, load flow, load flow. This is one way. Another way, in icon bar, you can go through this icon that calculate load flow directly available. So we go legally from calculation, load flow, and load flow. These are some definitions that how we our active power control, like this, like these parameters, we do not touch anyone, execute. Now we go through our system. You can consider, okay, now you can observe, you can observe from here that what was the voltage that we have defined in a terminal voltage 1110 and 1 per unit. This is the angle that we have defined. For another bus bar that we have defined, it was 1110, it was rated, and per unit we have selected for definition of each bus bar. Now what our actually in the practical, what will happen when the actually load flows and when the load is connected, our system is on, what happens? The next bus bar terminal voltage is 92 instead of 1110, and it becomes 0.84 according to our base, and by angle of 0.2 degrees. This is our load defined, that we have defined that 9.3 something and 4.6 something active and reactive power. How much current flows is given here, that is 0.065 kiloampere current will flow through to this load. And here the negative sign is shown, the same value with negative sign, that it means that it draws this amount of the current and power from the system. This is our transmission line. Now at the initial starting point of transmission line, our active power should be 11.2 megawatt, 5.5 MVAR reactive power, and the current drawn is 0.065 kiloampere. This is our required system capability that should fit to this much of the load.